Struggling with chemistry or physics? I can help. In teaching science, humor and analogy are two of the most important tools in my toolbox. In the following, I incorporate both in explaining collision theory. An important topic in chemical kinetics really breaks down what exactly must take place for a chemical reaction to occur.
Cool. Talk just briefly about collision theory, last topic of the night. Collision theory just lays out for us what requirements must be met for a chemical reaction to take place. These are the three requirements that have to happen. So if two molecules are going to undergo a chemical reaction, they have to collide with each other first. But it's not just enough for them to collide. They have to collide with the proper orientation. The parts of the molecule where bond formation and bonds breaking is happening, where that new bond creation is happening, those are the parts of molecules that actually have to come in contact. If it comes in contact with the wrong parts, no reaction is still going to happen. So it's not just enough for a collision. The right parts of the molecule have to be in contact during that collision, proper orientation. But even then, it's not enough. They have to collide with enough kinetic energy, enough energy to get over the activation energy barrier. So there has to be sufficient energy during that collision. So we're going to do a mock chemical reaction. And you sat in the front row, Quinn, and I'm going to use you. Do a fake chemical reaction. We are going to call this chemical reaction beating up Quinn. I know, it's terrible. Sorry, Quinn. So for this fake chemical reaction, you better believe there's going to be a collision. Sweet, but what you might not know about Quinn is a master of 18 different martial arts. She can kill any one of us with her pinky. In fact, she could kill all of us at the same time with just one pinky. So if this reaction is going to work, it's not only is there going to be collision, there's going to have to be proper orientation. You just turn and face that way. Keep going, keep going. Sweet, I don't want you to see this coming. It's called the sucker punch. So if this is going to work, she can't see this coming, or else if we're going to do beating up Chad, and I don't like that reaction very much. So keep facing that way, sweet. So in this case, though, it's not just enough that there's going to be a collision. It's not just enough now that we have proper orientation. If I just give her kind of like a little kindergarten punch, then she's going to turn around, and we're still going to be doing beating up Chad. So there has to be sufficient energy so that at least she's unconscious at the end of this collision for a sufficient period of time to where I can run away and get away unscathed. Thanks, Quinn. Sweet. So there's your demonstration of collision theory. Not only are these the three requirements that must be met for a chemical reaction to take place, they're also often what we use to explain why most chemical reactions go faster at higher temperatures. So why, according to collision theory, why would a reaction go faster at a higher temperature? More collisions. So at higher temperatures, we say that it increases the collision frequency. Just means you get collisions more frequently. All that means. Cool. Why else? Good. At a higher temperature, the average energy of the molecules goes up, and so you have a higher, we might word it this way, a higher percentage of high energy collisions. Higher percentage of high energy collisions. Now, if you recall, we said that, we said this with gases a while back, that the higher the temperature, the higher the average kinetic energy of molecules. Notice we had to say average, though, because some molecules are faster, some are slower. And the idea is that as you raise the temperature, that average goes up. But still, some of the molecules are still not going to have enough energy to get over that activation energy barrier. So let's say we do another fake mock chemical reaction here called escape from the hungry lion. So let's just pretend that I've been starving a hungry lion for the last week, and he's right behind this door. And I'm going to open this door and let him in, and then I'm going to take off. So, and if you can't run a 4.740, you're getting eaten. That's the way it works. So 4.740 is like really pretty decent high school athlete level. So most of you guys are getting eaten, sorry. It's kind of the way it's going to work. So on the other hand, you guys are the low temperature example. So we're going to bring in last year's Boston Celtics, seat them in here instead of you. This would be the example of heating up the molecules. And so notice, Boston Celtics versus you guys. On average, are they faster than you? Yeah, so that's kind of my example again of high temperature. But again, it doesn't mean they're all going to escape. Shaq is still going to die. So now the rest of them on average are probably going to make it out of this room, and a greater percentage had enough to undergo this chemical reaction, but not everybody. So that's what we mean by a higher percentage. Not all molecules will have enough energy to go over the activation energy barrier, but a greater percentage now will at a higher temperature. So these are the two places where we explain, according to collision theory, why most chemical reactions go faster at higher temperatures.
If you found that helpful, we have a comprehensive video library for your core high school and college science courses, as well as for the specific science material you might need to relearn if you're taking the MCAT, the DAT, the OAT, or the PCAT. Come check us out at CourseSaver.com.